Good morning, children. In today's class, we are going to learn about a new term called permutation. What does permutation mean? Permutation is nothing but order of arrangement. See, if I select 3 girls from your class, there are 3 girls in front of me. I want to give them some arrangement. How all can I arrange them? First girl, second girl, third girl. Or I can say first girl, third girl, second girl. Or I can say second girl, first girl, third girl. Or I can say second girl, third girl, first girl. Or still I can say third girl, first girl, second girl. Or third girl, second girl, first girl. See the variety of arrangements that I have. 1, 2, 3. 3 students are there. But when I say just go and sit, they can sit in this many ways. So this particular exercise, we are going to discuss how many ways can we arrange. So arrangement is an important word. So it is just not a selection of 3 girls. I have to give them some seat. So seating arrangement. This seating arrangement in a row. So there are how many ways? 6 ways I can call. Write this as 3P2. P stands for arrangement. 3P3. P stands for arrangement. There are 3 children. I am giving them 3 seats. There are 3 children. I am giving 3 seats. So 3P3. 3P3 I can also write 3 factorial. See, for example, there are 3 boxes, 3 places. Out of the 3 children, one of them go and sit, any of them. So 3 ways. How many remaining? 2. The second place, this child who is sitting in first place cannot sit here. So out of the 2, 1 will come here. Remaining 1. Out of the 1, 1 will come here. So 3 into 2 into 1, that is 6, which can be written as 3 factorial. So remember, 3 places, 3 children in a row can be occupied by 3 factorial ways, or in general NPN equals n factorial. What is the formula for NPR? N different things taken R at a time, we say n factorial by n minus R factorial. So permutation, the formula that I use is NPR. Earlier I said if there are 3 places, 3 children are going. How many ways? 3 into 2 into 1. Suppose there are 5 children, but there are only 3 places. How many ways can I arrange them? Here, out of the 5, 1 will go. Here, the remaining 4. Here, the remaining 3. So, these are the options. So, I will call this as 5P3. So, how to write 5P3? 5P3 is nothing but 5 into 4 into 3. Now, generalize the formula. How to write NP3? N minus 1, n minus 2. 5 minus 1, 5 minus 2. So, I will write n minus 1, n minus 2. Then what is NP2? n minus 1. What is NP1? N. What is NP4? How will I write NP4? n minus 1, n minus 2, n minus 3. If it is NP11, NP13, can I be writing all this? So that is difficult. In that case, use this formula. Now the question is, what is NP0? If I apply in this formula, it is n factorial by n minus 0 factorial, which is n factorial by n factorial, or I will get 1. So, NP0, whenever it comes, Remember, the answer is 1. NPR can also be written as P of N comma R. Another notation for NPR. In one word questions, if you get like this, you must know. If I tell you P of 5 comma 3, this is the meaning. 5P3. P of 5 comma 3 tells me 5 into 4 into 3. Find out the answer. So either we can say 5P3 or P of 5 comma 3. The next idea, there are certain letters that repeat in a particular word. How many ways can I arrange it? M, O, M. There are 2 M's. So if I try to arrange them, one method MOM, second method MMO, third method OMM. Can I write in any other method? No. So MOM, there are 3 letters in which 2 letters are same. When I write in same color, they all will look the same only. So there are only 3 different arrangements. I cannot put this M here and this M here because again it will be MOM, mom only. I cannot put this M here and this M here because M's cannot say I am first M, I am second M, all that. So whenever letters repeat, how to arrange them? There are 3 letters given, 3 factorial divided by. There are 2 letters repeated, so 2 factorial. So M repeated 2 times, tell me divide by 2 factorial. 3 factorial is 1 into 2 into 3. 2 factorial is 1 into 2. As I cancel, my answer is 3 and I get the 3 different arrangements. So whenever letters are repeated, divide that many factorial of the letters repeated. Another example, tell me for madam. Here, how many letters are there? 5. So what is my answer? 5 factorial. How many M's are repeated? 2 times M is repeated. So 2 factorial. 2 times A is repeated. So 2 factorial. So what would be my answer? 5 factorial is 1, 2, 3, 4, 5. 2 factorial is 1 into 2. 2 factorial is 1 into 2. Cancel and then write the answer. So my answer will be 30 times I can arrange this letters of the word madam. So in your exercise, when some words are given, check out whether any letter is repeated. So here no letter is repeated. So my answer is 5 factorial. There is nothing to be divided. But certain words where the letters are repeated, try to divide. How many times they are repeated, that many factorial. Circular permutation, the very next idea. You are arranging 3% around a circle. Can you tell me which is the first place in a circle? If I tell you row-wise arrangement, this is first place, second place, third place. So I can tell one of you go sit in the first, one of you go sit in the second. So like that I can mention. But when it is a circle, we cannot fix in the circle this is the first and on. So as I round it, everything looks a first. So fix 1% in the first place. The remaining 2. So A is fixed in a place. So that being the first place. The remaining 2 places only we can arrange. Either B here and C here or C here and B here. How many ways? 2 ways only. There are 3% in a circular table or in a circular arrangement. They can be seated only in 2 ways. How to get it? This is nothing but how many persons are there? 3. In which -1. Why do I -1? 1 person is fixed in a place to start with. That 1 person subtract. the remaining factorial. So I will say there are n persons sitting in a round table or a circular table. We will say n minus 1 factorial. Why do we minus that 1? That 1 represents one person who sits first and starts the game or starts the position. So in a row arrangement, I cannot say this is first. I have to mention this is first. So this is in a linear arrangement. But in a circle, fix a person and that will be the starting point. The remaining can be arranged in the remaining places. So the remaining only is arranged. So the remaining is nothing but n minus 1 factorial. The next idea, circular permutation of identical things. Suppose all the three are same A only. Are they looking different? No. A. Here also A. In the previous case, BC I interchanged. But here both are same. So how many different arrangements? Only one. This will not come. So how many ways I will say? Only one way. How to get it using the formula? 3 minus 1 factorial divide by 2. So 2 factorial by 2 gives me only one arrangement. So in general, permutation of n identical things, I will say the formula n minus 1 factorial by 2. Where do you get this identical things? The roses, garland. So here and all, you have the garland is like this. The beaded chain, what you are wearing, all this will be of this pattern, which it is all looking like a circle, but all the beads are same. I cannot say this is first bead, this is second bead, all that. So when identical things are strung in a circular pattern, a garland or a beaded chain or even flower arrangement, so whenever it is in a circle, identical toys I can put in a circle. So these are the examples in which remember the formula n minus 1 factorial by 2. Why do I divide by 2? Whether it is clockwise direction or anti-clockwise direction, it looks the same. Whether I go in this way or I go in this way, they are going to be one and the same. So clockwise, anti-clockwise, we cannot differentiate. So whenever they are identical, remember the formula n minus 1 factorial by 2. The next idea, given 6 digits, let me say, you want to form a 3-digit number. How many numbers are given? 6. What you want to form? A 3-digit number. That means at a time, maximum I can take 3 numbers from here. In this case, repetition is allowed. What do you mean by the word repetition? I can put 1, 1, 1. That is a 3-digit number. I can put 2, 2, 2. That is also a 3-digit number. I can put 1, 2, 3. So all these are examples for a 3-digit number. How many ways can I do it? How many numbers are there? 6. So what will come here? Any of the 6 can come. Again, how many are there? I had 6. Repetition allowed. The same 6 is again with me. So 6 can come here. The same 6 is again allowed because repetition is allowed. The same number can come again and again. So here also 6. What is my answer? 6 into 6 into 6, or I get 6 power 3. How to get the 6 power 3? How many numbers are given? 6. How many I want to form? 3. So what is my answer? 6 power 3. Whenever repetition is allowed, I can use this formula. We just list out all that we learnt. NPR equals n factorial by n minus r factorial. NP0 is 1, NP1 is n, NP2 n into n minus 1. NP3 is n into n minus 1 into n minus 2. 5 children can sit in 5 places in 5 factorial ways. So 4 in 4 factorial, 3 in 3 factorial, or in general, we can call this as n in n places. implies n factorial, and all that we learnt is linear arrangement. When it comes to circular permutation of n different things, n minus 1 factorial, n identical things we call n minus 1 factorial by 2, n different things taken r at a time where repetition is allowed. It is n power r. N different things, but P are of one kind in that and Q are of another kind. So here we take n things at a time, but P are of same pattern, Q are of same pattern. In this case, divide this factorial, n factorial by P factorial into Q factorial. Exercise 2.3, question number 1. If np4 equals 12 np2, find n. How to expand np4? N minus 1, n minus 2, n minus 3. How to write np2? N minus 1. Now, which all I can cancel? N and n minus 1. What is remaining? N minus 2 into n minus 3 equals 12. Or multiplying this, n square, n into 3, 2 into n, 2 into 3. Minus 12 equal to 0. Rewriting this, n square minus 5n minus 6 equals to 0. Factorizing, minus 6, I want minus 5. 6 into 1. Minus 5 tells me minus 6 plus 1. Check whether it is correct. Minus into plus minus. 6 ones are 6. Minus 6 plus 1 is minus 5. So I get n minus 6 into n plus 1 equals to 0, or n is equal to 6 comma minus 1. Now we are in the chapter permutation. Can n be negative? No. Out of positive things I can select, arrange all that. So n equal to 6 is valid. Ignore the negative number. So n equal to 6 is valid. The question is find n, and n is equal to 6. Exercise 2.3, question number 2. In how many ways 5 boys and 3 girls can be seated in a row so that no 2 girls are together? There are 3 conditions. First thing, 5 boys. No condition for the boys. Tell me, 5 boys can sit in 5 places in how many ways? 5 factorial ways. This is first step. Second, 3 girls are there. So 3 girls, is there any condition? Yes. What is the condition? No 2 girls are together. So where and all the girls can come? A girl can come here or here or here or here. So like this, how many places are there? They are not together. I cannot put 2 girls here itself. So the girls are alternatively seated. How many places? 1, 2, 3, 4, 5, 6. So there are 6 places for 3 girls to sit. How many ways can they sit? 6 P3. 6 are there, but only 3 are going to sit. So 6 P3. What is the total number of permutations? Multiply 5 factorial into 6 P3. As I expand, 5 factorial is 1, 2, 3, 4, 5, and 6 P3 is 6 into 5 into 4. Multiply it all and write your answer. So we have found out 5 boys, no condition, 5 factorial, 3 girls not together. There are 6 places for 3 girls, so 6P3. 6P3 tells me 6 into 5 into 4. 5 factorial is 1 into 2 into 3 into 4 into 5. Multiply and write out the answer. Question number 3. How many 6-digit telephone numbers can be constructed with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 if each number starts with 35 and no digit appears more than once? So what are all given? First, we want to form a 6-digit telephone number. So put 6 boxes. Second, how many digits are given to us? 0 to 9. So given digits are 10. Each number starts with 35. So put 3 and 5 in the first 2 boxes. No digit appears more than once. So 3 and 5 I cannot use again. So already used 3 and 5. So how many digits? 2 digits. So how many digits are remaining? Out of 0 to 9, remove 3 and 5. So 10 minus 2 equal to 8. So the balance digits are only 8. Out of the 4 boxes, 8 can come here. The remaining 7 can come. The remaining 6 can come. The remaining 5 can come. And what is my answer? Multiply and write it. This is short form of writing the answer. This is in detail. You have to copy both in the notebook, but you can prefer whichever way you want to write. Number of permutations, the balance boxes, 8 I have, 4 are the places. So 8P4, which is 8 into 7 into 6 into 5. Multiply 1680 is the answer. Question number 4. Find the number of arrangements that can be made out of the letters of the word assassination. As I read out the word, count how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 letters which can be arranged in 13 factorial ways. 13 letters can be arranged in 13 factorial ways. But certain letters are repeated. Which letters? Say yes. 1, 2, 3, 4. So S is repeated 4 times. So 4 S can be arranged in 4 factorial ways. How many A's are repeated? 1, 2, 3. 3 A's can be arranged in 3 factorial ways. How many N's are there? 1, 2. 2 N's can be arranged in 2 factorial ways. How many I's are repeated? 1, 2. So 2 I's can be arranged in 2 factorial ways. As I check, there is no other letter repeated. So number of distinct permutations. Total number of letters 13 factorial divided by how many times each is repeated. 4 factorial, 3 factorial, 2 factorial, 2 factorial, and that is the answer. If possible, expand it. What is 13 factorial? 1, 2, 3 up to 13. 4 factorial 1, 2, 3, 4. 3 factorial 1 into 2 into 3. 2 factorial 1 into 2. This is also 1 into 2. Expand it. You can use calculator. Simplify the answer. Otherwise, leave the answer like this. So we'll see, this is repeated permutation. Total number of letters factorial in the numerator. How many times repeated? Put it in the denominator, and this gives me number of distinct permutations. Question number 5. In how many ways can 8 identical beads be strung on a necklace? 8 identical beads. So identical necklace tells me it is a circular arrangement. So what is the formula? 8 minus 1 factorial divide by 2. Circular tells me subtract 1. Identical tells me divide by 2. So what is the answer? 7 factorial by 2. Second question. In how many ways can 8 boys form a ring? A ring is also a circle. Circular arrangement, but boys are different. So different things in a circle. The formula is 8 minus 1 factorial, or I will say 7 factorial. Let us mention the formula. Circular permutation of n different things is n minus 1 factorial, and n identical things is n minus 1 factorial by 2. So mention the formula, and these are all like one word questions but may come in 2 or 3 marks also.